Good morning, students. How are you? I hope you are doing well. Now, in our today's topic, we will going to discuss some of the important terms that are related to the topic atomic structure. In our previous lecture, we have learned about the electronic configuration and the methods to write the electronic configuration. So now, our today's topic is some of the important terms related to structure of atom. So, in this sequence, we have the different terms that we will discuss one by one. So, our first term is atomic number. Our second term is mass number. Third term is isotopes. So, firstly, we will discuss about these three terms. So, in this sequence, we have our first term, that is atomic number. So, what basically the atomic number is? Atomic number is basically the number of protons present in any nucleus of an atom. If I consider an atom, in the center part, we have a nucleus. This is called nucleus. These are the shells, and these shells are called orbits. If I talk about this nucleus will constitute neutrons and protons. It means the center part will be the sum of neutrons and protons. So, in this nucleus, we have N plus P. N is basically the number of neutrons and P is number of protons. So, nucleus will be the sum of N and P. So, in the nucleus, we can write N plus P. In the shells, these shells are basically called as orbits. In these orbits, the electrons will get revolved. So, we have different electrons in different shells. And actually, after the nucleus, we have 4 shells here, that is K, L, M and N. So, we can write it as K shell, L shell, third is M shell, and fourth is N shell. So, these are basically the shells after having the nucleus. The center part is completely positive, which is the nucleus. So, this is the basic structure for an atom. This is structure of atom and its subatomic particles. Now, we will going back to our terms that we are going to discuss in this chapter. Our first term is atomic number. So, I have told you earlier, the atomic number is basically the number of protons present in the nucleus. So, atomic number is the number of protons in nucleus of an atom. So, here it is our first term, that is number of protons in the nucleus of an atom. The atomic number is basically represented by a term Z. It is represented by symbol Z. So, Z will going to tell us about our atomic number, and Z will be equal to number of protons, or we may say that it will be the atomic number of that element. So, here is a symbol of atomic number, that is Z. Now, atomic number will be cleared. I am considering an example here. Suppose we have sodium, and this sodium can be represented as Na1123. So what is happening here? 11 here will be the atomic number of the element which is written in the lowermost part of the symbol, and 23 is calculated as the atomic mass of that element. So atomic number will be the number of protons present in that sodium. So number of protons equal to 11, Z equal to 11, and finally atomic number equal to 11. So it is all about the atomic number of an element, which we have to remember from approximately 1 to 40 from our exam point of view or solving some sort of numericals. Now we are proceeding to our next term, that is mass number of an element. As the name suggests, mass number or mass will be the sum of the two things. So mass number here will be actually the sum of neutrons and protons present in the nucleus of an atom. So now our second term is mass number, and we have mass number is sum of neutrons and protons present in nucleus of an atom. Present in nucleus of an atom. So it is actually the mass number of the element, that is n plus p. Mass number is basically denoted by a symbol capital M. It is denoted by symbol capital M. Capital M, and we can also write the mass number of an element M is equal to n plus p. Here n will be the number of neutrons, and p will be the number of protons which is present in the nucleus of an atom. So mass number is equal to M equal to n plus p. N is neutrons and p is protons. So now we will consider an example for calculating the mass number of an element. Suppose I am writing, we have example here. Suppose I am writing a carbon having atomic number 6 and mass number 12. So this mass number will actually be double of the atomic number. In some cases the mass will be different, but in most of the cases the atomic number is doubled and we will get the mass number. So here 6 is the atomic number of the element and 12 is basically the mass number of the element. So 16 is atomic number and that 12 is mass number. Atomic number is represented by Z and mass number will be represented by capital M. So it is all about the atomic number and mass number of an element. Now we are proceeding to our next term, that is isotopes. Here, as the name suggests, iso means same. So isotopes are actually the substance which have the same atomic number. So what are isotopes? Isotopes are the elements having same atomic number. So elements having the same atomic number are considered in the category of isotopes. Here the word iso means same and tops means element. So isotopes will having a same atomic number. Now we will consider the example for the isotopes. We have different example for isotopes. Firstly, we will consider the isotopes of hydrogen over here. If anyone wants to copy it, please copy it now. So now we are proceeding to the examples of isotopes over here. So our topic is isotopes. Isotopes means having a same atomic number. Now we are considering an example for isotopes. We have taken an example of hydrogen over here. Hydrogen is basically present in three isotopic forms, that is, first one is protium, second one is deuterium, and the third one is tritium. So here we have the three isotopic forms of hydrogen here. First one is protium, second is deuterium, and the third term we have is tritium. Now we will write the symbolic representation of this. We have symbols. Protium can be written as 1H1, deuterium can be written as 1H2, tritium can be written as 1H3. Now what we can observe from here, the atomic number, that will be the number of protons, will be written in the lowermost part of this subscript, and 1, 2, 3 that is written in the uppermost part of the element is regarded as a mass number. So firstly we will write about the atomic number. Atomic number here is 1, 1 and 1, which is written in the lowermost part. Now we have number of protons. Number of protons is actually the atomic number of the element, that is equal to 111. Now we will calculate the atomic mass of the element. Our third term is atomic mass. Atomic mass for protium is 1, for deuterium it is 2, and for tritium it is 3. Now atomic mass will be the mass number of the element. So we can also write mass number equal to 1, 2 and 3. So what we have observed from these three elements, the atomic number, or we may say that the number of protons are same in all these three categories. So these three are regarded as a isotopes of that element. So these are actually the isotopes of hydrogen. Now we will want to calculate the number of neutrons in all three. So we will calculate the number of neutrons here. We know that mass number will be the sum of number of protons and neutrons. So we have m equal to n plus v. This is a formula for mass number. Now if we want to calculate the value of n from here, what we will do, n is equal to m minus p, and we will simultaneously calculate the number of neutrons in this sequence. So we have next number of neutrons, and it will be calculated as m minus p. So what we will observe here mass number is 1 and number of protons is also 1. So the number of neutrons will be 0. Mass number 2, number of protons 1, so neutrons will be 1. Mass number 3 and number of protons 1, so the number of neutrons will be 2. So number of neutrons in this equation will be neutrons for protium, deuterium and tritium will be calculated as 0, 1 and 2. So these are actually the number of neutrons in all these three isotopes. So I hope the term isotope has been cleared to you. Now we are proceeding to our next term, that is isobar. So what are isobar? Iso means same and the bar means mass. So the elements having the same mass are considered in the category of isobars. So in different terminologies, we have discussed, first we have discussed about isotopes. Second category we have is isobars. So isotopes have been discussed. Now we are proceeding to our next term, that is isobars. So what are isobars? Isobars are the elements having same atomic mass. These are the elements having a same atomic mass. Elements with the same atomic mass can be considered in the category of isobar. In the category of isobar, we have an example for carbon and nitrogen. We know that atomic number for carbon is 6, but it can be occurred in two isobaric forms, that is carbon 12 and that is carbon 14, and nitrogen is having a mass 70, 14 have an atomic number of 7. So what we will do now, we will discuss the example for isobars. We have an example. We have taken 6C12 C614, that is the isotopic form of the carbon 14, and second example we have taken nitrogen having 7 atomic number and 14 atomic mass. So what we have observed from this, the carbon 14 and nitrogen 14 will have the same atomic mass here, same atomic mass. So these are considered in the category of isobars. So these are the both isobar of the element. So isobar has been cleared to you. So after isotopes and isobars, we are proceeding to our next term, that is isotones. So what actually the isotones means? Isotones means the elements having the same number of neutrons. So we are on our third term, that is isotones. Isotones means elements having same number of neutrons. So if the number of neutrons are same, these are considered in the category of isotones. Now we will take an example to understand what actually the isotones are. So we have an example for isotone. Here we will take an example for isotones. Isotones means same number of neutrons. We have taken an example for carbon 614, that is the 14, carbon exists in two allotropic forms, that is carbon 12 and carbon 14. Here we have considered an example for carbon 14, and what we have taken O816. So what we have observed from the above two examples, see here the number of protons are, in carbon we have 6 protons, that is written in the subscript, and oxygen is having 8 protons, that is written in its subscript. Now we will have a mass number. Mass number for carbon is 14, and for oxygen it is 16. Now we want to calculate, or we want to prove the number of neutrons in both these formulas. So now we will calculate the number of neutrons. Number of neutrons can be calculated as N is equal to M minus P. So what we have observed from here, 14 minus 6 will give us 8, and 16 minus 8 again give us 8. So carbon 14 and oxygen 16 is having the same number of neutrons here, that is 8 and 8. So these are considered as a isotonic species, or we may say that these are isotones. So I hope isotones have been clear to you. Now we are proceeding to our next term, that is isoelectronic, or we may say that isoelectrons. We have discussed isotopes, isobars and isotones. Now we are on our fourth category, that what are isoelectrons. So what are isoelectronic species? As the name suggests, iso means same and electrons means number of electrons. So the species having same number of electrons are considered in the category of isoelectronic species. So elements having same number of electrons is called isoelectronic species. It means it will having a same number of electrons. Now we will discuss it more with the help of the example, that what actually the isoelectronic species are. So I have taken an example over here. Suppose we have argon, Cl negative, Ca plus 2. So we know that atomic number for argon will be 18. See, chlorine is having a negative charge on it. We know that chlorine is having an atomic number of 17 and having a negative charge on it. It means it have acquired the one electron from its neighboring atom. So we have 17 plus 1, that is equal to 18. Now we are considering the example for calcium. We know that atomic number for calcium is 20, and what we have observed there, calcium is having atomic number 20 and it is carrying a charge of plus 2 over it. It means it have a tendency to lose 2 electrons. So what will be the number of electrons remaining here? 20 minus 2, that is equal to 18. So from all above 3 elements, what we have observed, that the number of electrons in all 3 are 18, 18 and 18. So we can say that 3 species are isoelectronic in nature. So these are the isoelectronic species. It means they are having a same number of electrons present in the shell of an atom. So Our fourth term was isoelectronic species. Now we are proceeding to our next term, that is isodiasters. Isodiasters means the compound having a same number of atoms and protons. So we are on our next term, that is isodiasters. We have our next term, isodiasters. Iso means same and diasters means having a same number of atoms or protons present in the atom. So isodiasters is the species or the substances, these are actually the substances having same number of atoms and protons. So these are actually not the elements, these will be in the substance or compound form having a same atomic number, having same number of atoms and having the same number of the protons. We have example in this category, that is CO2 and N2O. So these both will consist of number of protons and atoms that is equal to 22 in it and 22 in it. So this is considered in the category of isodiasters. So we have discussed our next term, that is isodiasters. Now proceeding to our next term, we have a next term, that is isospheres. So we have our sixth term, that is isospheres. Now we are going to discuss that what actually the isospheres are. Isospheres are actually those elements or those species which have the value of n minus p that is equal to 0. So we have a definition for it, that is species having value of n minus p is 0. So isospheres are the species having a value of n minus p equal to 0. It means number of neutrons and number of protons are same in it. So we have our next term, that is isospheres. I hope these terms has been clear to you. So these are the important terminologies related to atomic structure. I am again repeating it in a very short form, that is first is isotopes. Isotopes means same number of protons. Isobar, it means having a same atomic mass. Isotones, these are the species having same number of neutrons. Next, isoelectronic. Isoelectronic means these are having a same number of the electrons. Isodiasters, it means having number of protons and number of atoms same. And our last term is isospheres, having the value of n minus p that is equal to 0. So these are the basic terminologies we have in our chapter. Now we are remain with the two more terminologies that we will discuss now. Our next terminology is kernel and core. So what is core and what is kernel? So we are on our next term, that is kernel, and our second term is core. So what actually is kernel and what is core? I'm telling you now. Kernel means if an atom has a number of shells, the number of shells remaining after removing the outermost shell of an atom is known as kernel. So what actually the kernel is? Number of shells remaining in an atom after removing outermost shell. If I remove outermost shell of an atom, the remaining part of an atom is actually known as kernel. So it can be explained with the help of a suitable example. Now I am considering an example over here. Suppose I have an example of magnesium. We know that symbol for magnesium will be Mg, and magnesium will having an atomic number of 12. So what we will have now, we will write the electronic configuration of that atom. So electronic configuration will be we have 12 number of atoms in the magnesium. So we can write its electronic configuration as 1s2, 2s2, 2p6, 3s2. 2 electrons, 2 plus 2 4, 4 plus 6 10 and 10 plus 2 12. That will be the atomic number for magnesium. So this is actually the electronic configuration for magnesium. Now what we are doing, we are removing that outermost shell of an atom. That is, if 3s2 is removed, what we will get? We will get 1s2, 2s2, 2p6. It means outermost shell of a magnesium has been removed. So this is known as the kernel of an atom. It means the part that will be remaining after removing the outermost orbit of an atom. So this is known as kernel. So this is all about the kernel. Now we are proceeding to our next term. Our next term is core. What actually the core of an atom is? The core of an atom is basically the outermost shell of an atom. So what is core? It is defined as an outermost shell of an atom. So it is actually the outermost shell of an atom. Again, we are considering an example here. If I have taken an example of chlorine over here, Cl here is chlorine. Cl is chlorine. Now we know that atomic number of chlorine is 17. So we can write it as chlorine 17. If I want to write the electronic configuration for this, what will be the electronic configuration? 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2 and 3p5. This will be the electronic configuration. But if I write it in the terms of KLM and KLM shell, KLM, we have 2 electrons in the K shell. Now we have 5 electrons in the L shell and remaining 7 electrons in the L shell can accommodate 8 electrons. So 2 in the K shell 8 in the L shell and we have 7 electrons in the M shell. So what we have observed, the electronic configuration for chlorine atom will be 287. If I consider this outermost electron, so it contains 7 electrons in its outermost shell, and these 7 electrons is known as the core electrons. So these 7 electrons are known as core electrons. So this is all about the few of the terminologies in this chapter we have discussed today. We have gone through many more terminologies, that is mass number, atomic number, isotopes, isobars, isoelectronic, isotones, isodiasters, and the difference between core and kernel. Next topic is our radioactive isotopes and the quantum numbers that we will discuss in our next chapter. So this is all over for today. Thank you so much and have a nice day.